Today we'll go into semester 3 topics, which is mostly concerning with statistics. So there are 6 chapters as usual in semester 3. There's data description, there's probability distribution, sampling and estimation, hypothesis testing, and chi-squared test. So first we go into data description. You see all of this is mostly about statistics. Means there's a lot of data calculation, not a lot of calculus. So mostly you will deal with data and find mean, mode, median, draw histogram, and so on. Okay, so let's just go to the first chapter called data description. Chapter 13. Okay, so chapter 13.1, first they introduce types of data. So there's two types. There is a qualitative data, which is data that cannot be numerically measured. So this means what? This means like could be something like they said what is the status of someone. Maybe they said macam single, how many person, divorced, how many person, widowed, how many person. That is qualitative. Sebab dia it's not number. For quantitative is something which is about quantity, means something that can be measured. For example, is in your family members ada berapa, how many siblings in your family. So maybe 2, maybe 4, maybe 5. So nampak dia adalah nombor. Kalau atas ni tadi dia sama ada single, widow is not number, qualitative. And we will deal mostly with quantitative data. Okay, quantitative data can then be separated into two categories, which is discrete data and continuous data. Discrete data means it is integers and it involves counting. For example tadi, the number of children in the families. So 1 ke 2 ke 3, so you have to count. Number of goals scored, sebab goal boleh jadi 1, 2, 3, dia tak boleh jadi 1.5. So this is also discrete. Maksudnya dia satu-satu. 1, 2, 3, 4. Number of customers pun mana boleh jadi 1.5 orang ataupun 2.5 orang. Dia mesti seorang. So just 1 or 2 or 3. Continuous data mean its measurement, you can measure it, or it means it can have decimal places. Maksudnya sama ada macam heights could be 1.62 or 1.6 or 1.54 or 1.50. Duration of match 34 minutes, 34.5 minutes, and so on. Time taken also is continuous data. Continuous maksudnya boleh wujud decimal places. Discrete maksudnya mesti count 1, 2, 3, 4, 5, 6, 7. Okay, next. Data can also be classified into ungroup data and group data. So what does it mean by ungroup data? Ungroup data maksudnya that is the first data that you gather from an experiment or a study. It can be a list of numbers or it can also be in a table form. So example of ungroup data is like this one. This data dia cakap how many children in the family. So they just, maybe student A ada 2, student B ada 2, student C ada 3 orang in the family, student D ada 1, and so on. So this is we call ungroup data. And then you can classify this, macam you nak simplify kan ni, you simplifykan macam tengok here, family yang ada seorang sibling ada 3, ada 1, 2, 3. So 3. Family ada 2 sibling ada 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 ni, and so on. So you see these two, walaupun dia ini adalah dia tak tabulate, yang ni dah tabulate, but these two we call this ungroup data. Okay, apa beza dengan group data is this one. This is group data. What is the difference is you have you ada macam interval here. Dia ada kelas. Kalau sebelum ni you see dia 1, 2, 3. It's not like 1 to 2 ke and so on. This is ungroup. Group maksudnya ada interval. Okay, and then samalah frekuensi apa, must be interval baru kita call group data. Okay, dia group kan data. Okay, next is another definition, which is frequency distribution. Frequency distribution is just a fancy name for a table ataupun table for the results. Ni tadi is the first table that we encounter. Okay, This one is what we call frequency distribution. Maksudnya dalam table tu ada macam dia punya information, and then ada this one, number of family is frequency, and frequency maksudnya how many. Okay, this one, this ungroup data we also call frequency distribution. Maksudnya distribution of frequency, it's just table lah maksudnya, frequency distribution saja je begitu. Okay, we go to 13.2. So in 13.2, all the data yang sebelum ni, which is in table form or ungroup data or group data, we can further represent it untuk senangkan kita macam extra information. Ada 4 ways we can represent the data. Could be stem and leaf diagram, could be histogram, cumulative frequency curve, or in other words OGIF, or box and whisker plot. So these two is new to you, stem and leaf and box, which nanti baru I go through. So today we will go to histogram and cumulative frequency curve. So let's go to histogram first. Yeah, just skip. Okay, histogram. We know that you dah tahu dah histogram bentuk macam mana. Histogram maksudnya dia adalah bar, maksudnya dia macam tu lah, macam tu. That is kita panggil histogram. Okay. So your histogram ni you boleh bahagikan ada 2 type. Sama ada equal width maksudnya ini maybe dia punya width maybe 2. Ni pun mesti 2, maksudnya equal width. Another type is unequal width, maksudnya could be ini 2, ini macam 5, and then ini 1, unequal width. Okay, and then further, histogram of equal width ada 2 type. Sama ada the height represent frequency, or the height represent relative frequency. And then histogram of unequal width ada 1 type je, which is the height represent frequency density. So first we will go to this first type, in which histogram of equal width, in which the height represent frequency. So we can see that by example 13.5. So dia bagi data, and then this data represent metal detector set of 1 passenger during a 6-hour period, during 20 consecutive 6-hour period. So maksudnya the first 6 hour ada 4, the second 6 hours 19 kali metal detector tu berbunyi. The third consecutive so ni 6, 12, yang 6 hours sepasnya 22 bunyi, and so on. Okay, dia cakap construct a histogram to represent the data. So I bring the data to the next slide. This is data tadi. The first thing we need to do untuk construct histogram is I need to group this data. Okay, so what I can do is I boleh classify dia from 1 to 5. Maksudnya I tengok ni ada 4, 1 to 5, 4, 2 dengan 5. So this one under 1 to 5, so ada 3 frekuensi, 1, 2, 3. From 6 to 10 ada sini 9, and then 8, and then 8, and then 10. So ada 4. 11 to 15 kita continue sampai the last one is 31 to 35. Next, how to draw the histogram must be on a graph table, on a graph paper, and then you see dia punya bawah ni, nombor-nombor bawah ni mestilah the lower boundaries and the upper boundaries. So you see for this one, the first one, 1 until 5, the lower boundary is not 1, it is actually 0.5. And the upper boundary is not 5, it is 5.5. So maksudnya antara 0.5 and 5.5, frekuensi dia adalah 3. So sampai di sini 3. Next, this one is not 6, lower boundary, it's 5.5. Maksudnya tolak 0.5. This one is not 10, it's 10.5. So daripada 5.5 sampai 10.5 should be 4. So 4. Okay. And then kalau kita ambil je yang last kali. Last kali the lower boundary 31 minus 0.5 should be 30.5. 35 tambah 0.5 is 35.5. From 30.5 sampai 35.5 should be 2. From 30.5 should be 2. Okay. So that is the first type of histogram, which is equal width, and then dia punya height represent dia punya frequency. Okay, we go to the second type of histogram, which is still the same, equal width, but the height now represents relative frequency. Okay, so dia bagi, this is for example 13.6, so dia bagi data, this reconstruct is a histogram. Okay, so I just tunjuklah histogram dia macam ni jawapan dia. Okay, so kalau for this one, apa beza dia dengan yang belakang tu adalah atas ni, dia adalah relative frequency. Dia tak ambil yang frequency ni, dia ambil relative frequency. Okay, it's not 24, dia ambil yang point ni. Also one more thing, you see, notice the difference here is dia ada inequality sign macam ni. Dia bukan macam tu dah. Okay, so ada different. Contohnya kalau you punya tadi daripada 5 until 10, lower boundary dia is 4.5 sampai 10.5. Tapi bila you punya data bentuk macam ni, X 5 10, okay, lower boundary you ambil terus 5, upper boundary 10 terus. Okay, bila sengkang kena tolak 0.5 plus 0.5. Bila tak ada sengkang, bila bila inequality macam ni, ambil terus. So for example here from 50 until 60, nampak tu, 50 until 60, relative frequency is 0.123. So dia buat dekat 0.1, 0.123. Okay, kita tengok yang last kali. From 110, 120, relative frequency is 0.031. Here, 110, 120, relative frequency is 0.031. Okay, so macam you maybe tertanya, mana actually dapat relative frequency ni, sebab you punya soalan dia terus bagi. But actually they get this relative frequency daripada, first kita totalkan this whole thing. Total dia sama dengan, so I kira 24 campur 30 campur 49, 40, 30, 16, 6. This is 195. So dapat daripada adalah 24 ni, 24 bahagi dengan 195, you will get 0.123. Maksudnya frequency divided by total frequency, you dapat relative frequency. Tengok yang second, 30 divided by 195, you akan dapat 0.154 and so on. Okay, ambil ini divided dengan kira semua ni tambah. That is relative frequency. Sebab kadang-kadang dia tak bagi this part, you kena kira sendiri. Okay, kira dia macam mana? Lain sekali, ambil frequency divide dengan total. Okay, so that is the second type of histogram. The third type of histogram is the one with unequal width. Maksudnya dia punya bar tu tak sama besar. And then the height represent frequency density. So we look at example 13.7. Okay, so they give data like this. Dia suruh you construct, calculate the frequency density, cari frequency density first, and then construct a histogram. Okay, so kita calculate dulu frequency density. Okay, so ni jawapan dia. Okay, so ni data, ni yang dibagi tadi. And then yang ni yang you tambah, frequency density ni. So macam mana kita dapat yang ni? 12 ni data daripada frequency, bahagi dengan 4. 4 data dari mana? Datang daripada upper boundary 7.5 minus dengan lower boundary 3.5. 7.5 minus 3.5 is 4. So 12 divided by 4, which is frequency density is 3. For this one pula dapat macam mana? 20 bahagi dengan upper boundary is 8.5, lower boundary is 7.5. 8.5 minus 7.5 is 1. So 20 divided by 1 is 20. Same for this one, upper is 10.5, lower is 8.5, which is 2. 18 bagi 29. Sampailah habis. So frequency density is this one, yang ni, data yang kita kira ni. Dish. Okay. And then for the histogram, kalau kita tengok on the x-axis should be lower boundary sampai upper boundary. So daripada 3.5 sampai upper boundary 7.5. Dia punya ni adalah 3. So ni 5, maybe lah 3 somewhere here. So ni 3. Next kita tengok, ini lower boundary 7.5 sampai 8.5. And then dia mesti 20. So ni 20. Daripada 8.5, 10.5 must be 9. So ni 10. Patutnya bawa dia 9. Somewhere there 9. Okay, and so on. So you see, ni nampak tak? Unequal width. Okay, so in a nutshell, ada 3 type. So the first one is histogram equal width. Kalau yang equal width, dia punya y-axis represent frequency. The second type also equal, y-axis represent a relative frequency. The third type is this one, which is unequal. Unequal. Y-axis represent frequency density. Frequency density. Okay, ada 3. Alright, so we continue. So kita dah siap histogram. Next is cumulative frequency curve ataupun OGIF. Okay. So macam mana nak buat cumulative frequency curve? I think first I need to explain apakah maksud dengan cumulative frequency. You already dah pernah belajar, tapi kot lah you lupa. Cumulative frequency maksudnya apa? Maksudnya sekarang, okay, kita ada, ini ada data, ini frequency. Selalunya you akan buat lagi satu column dekat sini, called cumulative frequency. Okay, and dalam column tu, cara nak kira. So, ni 3 kan? So, first you letak 3. And then, yang ni patutnya apa? 3 tambah 4. 4, 5. So, patutnya 7. 7 tambah 2, 9. 9, 10, 11, 12. 9, 10, 11, 12. So, ini patutnya 9 campur 5, 14. 14 campur 3, 17. 17 campur 1, 18. 18 campur 2, 20. So, this is cumulative frequency. Memula tulis, and then tambah. And then tambah. Okay. So, kita tengok example of cumulative frequency curve. Example 13.8. Dia bagi data. Dia suruh plot a cumulative frequency curve. Okay. You punya data ni senang sebab dia dah bagi cumulative frequency terus. Dia bukan bagi, so tak payah kira cumulative frequency dia apa. Okay. And then, kalau kita tengok, okay. And then, kalau kita tengok result dia. Also, here you see that this is maksudnya less than 10.5, less than 20.5, less than 30 and so on. Maksudnya dia tengah buat, maksudnya sini adalah antara 0 sampai 10.5. Sini adalah 10.5 sampai 20.5. Macam faham tak? Sebab ini kan semua ke belakang kan. Maksudnya dia maksudnya dia macam mana, dia dah tambah semua. Tak apa. Nanti you faham kot. Okay. So kita tengok dia punya macam mana bentuk cumulative frequency curve. Kita just tunjuk je. So cumulative frequency first curve, dia adalah curve, dia bukan histogram, dia tak ada bar, dia satu line je. Bawah ni you see, semua ni adalah upper boundary daripada yang belakang ni. Ni apa boundary every ni. Sebab dia ambil yang atas. Okay. And then upper boundary next adalah dia punya shape always like this. Dia tak akan jadi macam tu ke, macam tu. Dia mesti akan start daripada 0 naik macam tu. Okay. And then you see belakang ni kalau kita tengok bila 10.5 30 10.5 30. Bila 10.5 sini 30. Okay, bila 20.5 maksudnya I think 90 kot. Oops, 90. Oops, 90. Bila 30.5 190 and so on. So you see dia ambil upper boundary and then dia ambil cumulative frequency. So akan dapat this cumulative frequency curve. Alright. So that is all.